This video is the second part of our Helm chart we discussed in our previous video. So in last video, we faced an issue of while we deployed a Postgres database by using the Helm chart. So it was requesting for the persistent volume, but storage class was not working fine. That's why the persistent volume get into pending state. That's why we were not able to deploy our database by using Helm chart. So let me show you what happened. Yesterday I had this storage class, but the relevant resources of storage class were not working. So I delete the storage class and that in uh, we set up manual storage class in storage class concept video. So I delete everything and my cluster is up. And if I show you Helm list hyphen capital A will list you down all the namespaces Helm deployment. So we deployed this application, we deployed this PGTP chart in the database namespace, and it's in deployed. Even if I show you kubectl get persistent volume claim in database namespace, it's in the pending state because we don't have any storage class. Whatever value of storage class we provided in the values for this Postgres database deployment Helm chart, it is not available. It's not working properly. So yeah, first of all, we have to make sure our NFS uh, uh, storage class is working fine. So here is the NFS subdirectory external provisioner. We use this deployment manually. Now I will use this Helm chart for this deployment. And if I go to this install section, so you can see here, this is the repo with this name, and the complete repo will be pulled down from this URL. So I'm going to add the repo. kubectl. If I list Helm repo list, so here is this repo, and if I search Helm search repo, this repo name, so it will list us down all the charts available under this repo. So you can see there are a lot of charts available under this repo. This repo is also providing us Postgres, but this is from different vendor. Okay, so our concern is about the chart we want to install, and here you can see the installation of this chart is defined here. So NFS subdirectory external provisioner, and this hyphen variant is a chart variant. The variant I showed you, this variant is actually the chart we created. App1 chart, I believe we created in our last session. So I showed you this chart YAML. This is the app variant. So this is actually the chart variant. And if I show you this you can see this is the app variant is same like this one. Okay, and the chart variant is 0.01. So now if I again do a search, and here I search grep NFS, So there are a lot of charts available. So NFS provisioner, NFS client provisioner, NFS subdirectory external provisioner. This subdirectory external provisioner has the tendency to automatically create a new directory within the existing NFS share, and that will be used for the persistent volume automatically. These charts are working in different way. They need directly some share from NFS. They cannot create a new share from NFS, but this can create. So here you can see the variant is 4.0, 4.0.16, and here the same variant is mentioned. So this variant number mentioned is not mandatory. If you just apply this, it will automatically apply the same variant number. So let me install this external subdirectory, but this will not work because we have not defined where is our NFS server, where is our NFS server share. So those values we must have to provide at least. And we have not defined the namespace where we will install this chart. So first of all, I need to query my NFS server. So show mount, we check my master node can reach to my NFS server. And if you remember, we create this K8S all storage. I believe this was, let me just verify once that either this is working. Yes, this was the directory where that we defined. So all storage we will use for NFS provisioning. So it's mean this will be our share and this will be our IP. So to this Helm chart, we have to provide these values. So how we can provide the values? In our last session, I told you, I explained you in detail that Helm inspect values and then repo name / chart name. So it is printing all the value file in at once. So let me just throw this inspect values in some in temp location. I can say NFS chart dot values. And if I open this, so here the replica count for the container that will run our NFS engine to provisioner engine is value 1. It's good. I'm just concerning about this is the image that will be used. Okay, it will work. And this image is publicly exposed, so I don't need to provide any pull secret. If this is if a private image, then you must have to provide here the name of the secret that contain the authentication credential for to access this registry to pull down this image. So here, NFS. So here we have to provide the IP or the name of your DNS server, and here the path that we will use to as a share that will automatically create the directories inside this share. So this is a bare minimum changes we must be required to change to deploy this chart. And mount option, volume name will be created like this. You can change this. It will add some additional things, mean some serial number. And reclaim policy is retained. We discussed these in very detail when we cover our persistent volume and persistent volume claim. All those concepts you can see in those videos. So storage class, it will create, and provisioner name, it will create default storage class. Mean if you are not defining in your persistent volume claim the storage class name, the default one will automatically be used. So this storage class will become your default. You can have multiple storage classes in production environment for different that are pointing to different storage mechanism. And just like one storage class is pointing to NFS, second is to your cloud object storage, third one storage class for your block storage. So here we have only one storage class, so I will set it to true, so that if someone is don't know the name of the storage class, just leave it blank. It will automatically leave it empty. It will automatically use the default storage class. And the name of the storage class is NFS client. So you can change this. And storage class creation is true. So these are all the policy. Reclaim policy delete. Mean it will automatically delete the persistent volume. So I'm not changing these values. It's up to you how you are going to set up the storage. So whatever storages will be provisioned under NFS will all the persistent volume will be read-write once. So NFS is a type of storage that you can use for read-write many. So but for the database purpose, it should be read-write once. Okay. So, but it depends for which type of application, stateful or stateless application, you are going to use this storage class. I'm just leaving it read-write once, but you can change according to your requirement. And leader election is true, and role-based access control, it will create security policy, and the resource limit on the pod, that pod will be responsible to run the this engine of storage class will occupy these resources max. So it is a very small engine. These resources are good to use. I can extend it up to 500 millicore. And give it to 500 megabyte. Sorry, it's limit to 500 megabyte, 500 millicore. And here, okay, that's all. It's good. And now we have to install this chart, the name of the chart, I can define something like NFS storage provision. Okay. And or I can say NFS storage chart. And this is the repo name. This is a chart inside the repo, and in which namespace I would like to use a new namespace, just like NFS storage. And I know I don't have this namespace, so I need to add here create namespace, and I have to define values from temp NFS chart values. So this chart will deploy by using these NFS values. Failed error converting. There is some mistake has been done by me when I made some changes to this file line number 92. So here you can see, yeah, maybe there is some indentation issue. Limit memory requests. The mistake is I have not removed these curly braces, because these curly braces are representing unlimited resources. So this chart is deployed, and Helm list in namespace NFS storage. You can see this chart is deployed, and kubectl get all -n in database namespace in NFS storage. So this pod is created, it's up and running. This deployment is created, replica set, and there are a lot of other resources created within this namespace, or maybe on the cluster level for the role-based access control. We explained this in detail when I did the video for manual provisioning of storage class. So since we are using Helm chart, we don't need to worry about these things. If our pod is up and running, it's mean it is successfully connected with the NFS server. If our NFS server is down, it will not run. And the path we provided are correct. Now, if I look into kubectl get storage class, so you can see the storage class is set up as default, because I provide the Helm value, make this storage class as default. Now, if I go back to my Postgres values, just in last session we created. So here we provide the default storage class NFS client, okay, and the storage class, okay. Rest of all, we just made some minor changes, password. So let me check kubectl get pv-n database. Yes, you can see it was in pending state, but as it was waiting for that storage class. So as that storage class become active, it automatically provision 8 GB of storage for the database, and definitely somewhere inside these values, the size of persistent volume for this database is defined. If I go down, definitely there will be some portion where storage related persistent volume values will be available. It's about a primary, and let me just search for the keyword volume. Volume mount, persistence true, storage class. This is a size 8 GB. So here storage class is not defined, but it use the default storage class we define up. And access mode is read write once. You can change this, but for the database it's mandatory. It should be read write once. And then size is 8 GB. So you can change your size. 8 GB is very less. For in production you will change this. So far it's good. Our provision, and if I query CTL get PV, you can see the persistent volume is also created. And in our NFS server, a new directory is created. This one, database data PGDB Postgres. Okay, and if I go under this directory on my NFS server, so I can see the data directory is created and all the data files of this Postgres database are residing here. So it's good. Now let me check kubectl get pod in database namespace. So our pod is now up and running. It was in pending state. Okay, so now we can make, and if we look into the service, this service within the cluster, since I am working from a master node, so I can do a telnet to this cluster IP on 5432 is the port of this database, and it's reachable. Great. This means our database is up and running. Now we can make a connectivity with this database from within the cluster. And if you want to make the external connectivity, you need to expose the node port for this. So in your Helm chart, you can change this cluster IP to node port. So then you can access it. So this was an example I gave you where we deployed the two charts. One is Helm list. When we deployed three charts, I show you, this was our custom chart. This is NFS storage, this is Postgres database. Similarly, any product you want to install. So Helm will give you the great leverages to deploy the application. It will make your life very easy, but you need to spend some time to understand the concept of all the variables. So here, all the variable values are listed here. You can fine tune your Helm chart before deployment. So, and there is another way. I mean, if you don't want to pull out the value file, and you don't want to save the value file somewhere, and you don't want to edit the file directly, but you want to provide the values runtime at the runtime. So here is an example that install with this name. This is just a name. This from this repo, this chart, and hyphen set you can use to set directly some value runtime. So these two values, you bare minimum values we must have to provide. So here you can provide your NFS server IP and the path that you expose for the persistent volume creation. So you then with this way you can also provide the values. So here are multiple examples. So if we want to delete some chart, we can do Helm, for example, delete this app1 chart from namespace UAT. It will delete all the resources. See, it's removed. So you don't need to take care whatever resources are running behind, how many resources, API resources provisioned. So this will be the center point of your control of your whole application. If you, whatever application you are going to convert into microservice, you should create a Helm chart. So it will help you uh, to to provide this application to your customer or any end user. Directly, you can provide the Helm chart, and that Helm chart knows everything how to deploy this. Just make some variable definitions so that minor changes in the variables will be according to the environment. Some users would like to get the more CPU and RAM resources. They will change those values. And if your image is in some private repository, then you will provide some secret to pull down the image. So there's such type of changes you can do. So here we did this, but if I show you some examples of, for example, you want to do the MySQL. So MySQL charts are available, official chart and third-party charts are available. Whatever product name you name here, you want to monitor your Postgres, this Kubernetes cluster, you can deploy Prometheus. Okay, so this is a complete chart for the Prometheus. And on top of Prometheus, you need Grafana. Okay, so Grafana has its own chart. Okay, so we will do this first. I will do some videos on monitoring of Kubernetes cluster based on Prometheus Grafana with some exporters. But manually deployment is quite difficult as compared to this Helm chart. So if you need something that we did, for example, metric server. Metric servers where you can use for the Kubernetes. We deployed this manually, but you can Kubernetes metric server. It is mandatory for your HPA, horizontal pod auto scaling. Okay, so now you know how to work with the Helm. So there are some, I almost explain everything. This file is attached in the Git repo. You can read this. I gave here the bare minimum, the requirement of, I mean, these commands you should know if you want to work with the Helm. And almost we use all of the command, but one command that I would like to share with you that is very important. There is a history rollback we did. So if I do Helm history of this chart in namespace NFS storage. So right now, actually, we did multiple Now, if you did have multiple revision, it will list you down all the revisions. So far, we have only one revision. That's why it's showing me only one. But yesterday, in last session, we did applied multiple revision on this app one. It will show you at what time and date which revision was applied and what was the app version. And another useful command of Helm is fetch. For example, you have Helm repo list, you have multiple repo, and and you want to update these repos, so you can use Helm update. I think Helm upgrade. Uh, I believe we must have to. Don't remember exactly the command for the upgrade. Sorry, I don't remember that command right now, but the the command I was going to show you, the Helm fetch. So Helm upgrade some command that will refresh, because for example, you pull down this repo 6 months ago. Now still it is in your system, but on this URL it is updated. So you can run that command to update the latest uh, changes to your machine. So if I show you something like kubectl, sorry, Helm search, it's like Bitnami and search repo Bitnami. Uh, I will just get some random chart, for example, this sonar cube. Okay, I can use Helm untar, fetch untar, and then repo and chart name. Okay, so it will pull down the whole chart to your current directory where you are right now. So here I can show you what has been downloaded. This chart name directory SonarCube has been pulled down. Now if you go to this SonarCube, so you can see all the templates, values, file, everything. Okay, so if you go to these templates, so these are all the templates. You can see this is a value file. So this has become same like we created our chart, this app1 chart. So the directory structure is same, but I pulled down this from internet for to understand what is the complete directory structure available in this chart. You can see the value file. This is a value file relevant to this chart. Let's see the chart variant. Okay. So I hope you are good with this Helm now. We discuss everything in very detail. You can leave the question on my emails if you have any issue while you are deploying this Helm.